3 and step number 4. Kelly, can you help me read both step 3 and 4 in option 1, please? Yes, guys, check your answer. It's ultra, ultra, ultra important, okay? Step number 2, the difference is this. On step number 2, class, you have log base b of a equal to x. Is there another log on the right? No, so you may not drop it because it's not equal if you do. So, guess what you have to do if you were to solve for it? Rewrite it as an exponential. Remember, you can always go from log to exponential and vice versa. So, can you, Nico, help me read number 1? Keep on going.
Use the properties of the logarithm.
Logarithms.
If necessary.
To condense. You're right. If you have a lot of logs on one side and there's no log on the other side, before you can rewrite it in exponential, you have to condense all of the logs. Number 2, Jaden. Perfect. 3 and 4, Skylar.
Solve and check your answer.
Beautiful. Thank you very much. Okay. All right. Examples 1 all the way to 7. Alan, help me with instruction, please.
Determine which option to use and solve.
Perfect. Determine which option to use, then solve. What's up? What option do you want to use, Jonah?
Option 1.
Perfect. Question number 1, Jonah. Do you have one log on each side?
Yes.
Are the bases of the logs the same?
Yes.
Yes. So can I drop the logs?
Yes.
Yes. So if we drop the logs, Alicia, can you tell me what to write? That's right. Let's solve for this normally. What do you want to move first, please, Maurice?
2x.
Fine, good. Subtract 2x from both sides. Class, at the same time, can I add 5 to both sides?
Yeah.
Yep. Just 2. So that means 2x are gone. The 5s are gone. So you have 6 equal to x. Now, before you box it up, both sides, you need to check it. What that means is you have to plug it back in. So on the left side, 2 times 6 is 12 plus 1 is 13. That's a positive 13. Then on the right side, 3 times 6 is 18 minus 5. Also, what? 22. 18 minus 5. 13. They're both positive, right? And they're the same. So can I keep my 6? Yes, that's when we can box it up. Right. Number 2, log base 2 of 6 plus log base 2 of x equals to 3 without a log. What are you going to do? Not yet. I cannot write exponential if there are multiple logs in the equation. Condense it first. Let's condense the left side. How do we condense the left side? Multiply, because the log on the left sides are currently what? The same base, and they are being added. So that means when you condense, they become what? 6 times x. It becomes a multiplication. Okay. And again, there's no log on the right, so you have to rewrite it as what? Exponential. You're right. So Justine, help us out. How do you write that as an expo? You can consult with your members.
2 to the third power is equal to 6x.
2 to the third equals 6x. All right. Tell me, please. Jasmine, 2 to the third is what?
8.
Perfect. 8 equals 6x. This one goes to Matt. What's x then, Matt?
You got 6 and 8, so that is
4 over 3. Okay. Let's check it. Plug it back in. Positive or negative? Positive, so you can keep it. Okay. Am I going too fast? No. Yes. Okay. You're checking it because you want to make sure that log can't be negative.
That's it.
And also make sure it equals to the other side at times. Like number 1, it equals. Number 2, you don't have to, just make sure it's positive.
Is there any on these signs that it's not?
Well, I'll keep going. Maybe. Okay.
Wow.
All right. You try 3 for me, please. You have a minute, or actually, how about this? 2 minutes to work out 3. If you're done with 3, maybe get started on 4 on your own. Let me set the timer. If 2 is done, turn to somebody, check the answers, and move on to 4 if you're done before the timer. Bless you. Where's Claire today? Yes. You can see that she is not here.
Yes, I can.
Those of you who are friends of Claire, where is she? Is she okay?
Yeah, she was telling me like something happened last night. I don't know what happened though. I don't know what happened. It's like, hey, I'm not gonna be school tomorrow. Something happened to my house. It's like,
It's alright. It's alright. It's okay.
My story might have been better.
Oh. Okay, now 3. I want you to turn to somebody. It's like, hey, what'd you give a 3? Go.
Yeah, but everyone did negative, so I said no.
It's negative, yeah. Negative.
Wait. Oh, because I thought my 1 on 31 was parentheses.
Wait, you thought the 1 7 like it was like.
I thought it was just a 3 because the 1
Oh.
4 and she had.
Oh, I thought you.
All right, here we go. Ben, final answer. What do you have for on 3? No solution, Ben said. Okay. What made you say no solutions, Ben?
It's like when I worked it out, it equals negative 13.
Okay. All right. So Ben said when I worked it out, let me double check his work. Did you guys drop the logs?
Yeah.
Yeah? Okay. So we dropped the logs. You move the 1x over, so you have 5 equals 2x plus 31. Move the 31 over, so what's 5 take away 31? Negative 26 equals 2x, divide both sides by 2, so Ben's correct. Except that some of us are like, I'm just going to box that right up. Except you can't do that. What should you do? You have to do what? Check it. You have to plug it back in and check it, right? When you plug it back in, negative 13 plus 5 is? Negative answer. Negative what to be exact?
8.
Negative 8. Now let's plug into the right side. 3 times negative 13 is? Negative 39 plus 31?
Negative 8.
How come I can't keep it?
Because it's negative.
Right. But just don't take my word for it.
But you said that.
I did say that, and you're right. The answer is no real solution. But here's why. When I plug it in, aren't they equal?
Yeah.
Okay. But here's the reason behind why log can't be negative. You don't have to copy this down. Just kind of listen. If I give you a basic log, the easiest log I can think is this one. Yes or no? And I'm going to give you a picture to go along with it. To graph it out, I'm going to rewrite it as 2 to the y equals x. And then I'm going to go in, pick some points for y, negative 2, negative 1, 0, 1, and 2. And this is a positive quarter, a positive half, 1, 2, and 4. Would you agree with all of our points? Then from here, we are going to graph it out just like normal, no big deal. 1, 2, 3, 4, 1, 2, 1, 2. In logs, we know that x can never ever be what? 0. So that's why there's a vertical asymptote. Is that okay? And then I'm going to apply my points. A quarter goes down to negative 2. A half goes down to that, and 2 is 1, and 4 is 2. Okay, so look at this basic, very basic log. Most of the logs will look very similar. What do you see about the domain? It's not all reals. It's all positive. It can't even be 0. It can't even be 0. So when you get an x value, plug it back and it's 0. Can I even keep it? No, I can't even keep the zeros, okay? So make sure you plug it back to make sure there's no 0 around these things right here or negative.
What does the graph look like?
It doesn't even exist. It doesn't have one. If you plug in your calculator, it says not possible. So it's just a made-up equation. When you get to higher math, there'll be more stuff. Right now, it doesn't exist on the real number line. All right, 4. That one's easy. All right, you have 2 logs on the left and 1 log on the right. What are you going to do, y'all? Condense. All right, tell me how to condense it. Log base 5. Whoa, there's different colors. Log base 5 over 4 times x is 4x equal to log 36. Drop your logs. 4x equals 36. Divide both sides by 4. X has to be 9. Did you plug it back in? Yes. Okay. All right, 3 more. Log base 4 of x plus 2 times log base 4 of x minus 4 equals to 2. Oh no. Remember, you cannot drop in the log unless there's 1 on the right and 1 on the left. You cannot rewrite exponential unless there's only 1 log. What are you going to do? Condense the left side. All right, let's do condensing. On the left side, how are you going to condense that? Log base 4 of what? So what you're saying, you're going to multiply those two? You sure should. Okay. What do you do next? FOIL it out. Sounds beautiful. So log base 4. How do you FOIL that? Good. Can I simplify? Yeah? What is that becoming? Great. You have 1 log on the left. You may not drop that 1 log because it won't be equivalent. So what are you going to do? Yeah, exponents. Here we go. 4 to the what? 2 power equals to x squared minus 2x minus 8. Perfect. Killy. What's 4 squared? Beautiful. 16 equals x squared minus 2x minus 8. Have you seen these kind of equations before? No, never. So Sammy, where do you go from here? Yes, anytime you see a quadratic, you might want to set it equal to what? 0. Okay. So 0 equals x squared minus 2x minus 44. Oh, 24. Okay. What are you going to do here to solve x? Quadratic or factoring. Is it factorable? C. Can you give me the 2 factors when you are ready? Give me the whole 2 factors. X. X plus 6 or minus 6? Minus 6. I got the factors. How do you solve for x? Let's take each factor and definitely set it equals to 0. Very good. You have 2 answers, -4 and +6. Should I box them both up? No. Which one are you going to cross out? -4, because why? Yeah, when I check it, it makes all of that what? Negative, so I can't have it. So I will only box up 1. 6. Now what? Yes, Billy.
We still have like a negative answer. It's only not possible to plug it in.
Correct. Good. Okay, guys, Billy brought up a very good point. I can technically have a negative answer. Let's say that log base 6 of negative x equals to something, right? And you solve for x and you come out, let's say -6. Would you agree that I can keep that? Because when I plug it back in, a negative and a -6 make it a what? A positive. It's okay to have a negative x, just that when you plug it in, it can't be negative in the domain. Okay? Yes, Jason. Yes, because when I plug it back in, it causes my log to be negative. There isn't anything wrong with having an x value of negative if when I plug it back in, it's still positive. Okay? You're puzzling. No, I said there isn't anything having a negative x if when you plug it in, it makes it positive log.
No, it's not okay.
No.
For that one specifically, for the x equals -4.
I can't have it because in this case, when I plug it in.
Yeah.
That's what we're at.
You said it was okay.
No, for this case it isn't, but in Billy's answer, it's, I can have it. Okay, anyway.
That's an egg roll, y'all.
It's y'all.
So like, you know, it's like x plus 6, x plus 2, and x minus 4.
Yeah.
Obviously the answer would be different, but theoretically if that was like x plus 5, and then the other one was still made it negative, we can have it as
No. Both of them have to be, very good. Thank you for clearing that up. Both of them have to be positive. Okay? Thank you for clearing that up. All right. 6. Do I have logs on everything? No. 2 does not have a log. Now what? Yes? Yeah. Yes, let's move the log base 5 of x to the, what? To the other side, right? So 2 equals 2 times log base 5 of 10 plus or minus, if I move it to the right, minus log base 5 over x. Before I can condense, what should we do? You mean not drop, you mean raise it? Raise it, right? So the 2 in the front of log base 10, y'all, that's a coefficient of log. Coefficients of log become what? Exponent, right? So log base 5 of 10 squared minus log base 5 of x, okay? What's 10 squared? 100. So log base 5 of 100 minus log base 5 of x. How do we condense that? Divide. Tell me what do you write? 2 equals what? Log base 5 over. Thank you. How do you solve this? You don't? We don't ever? We cry? No, we don't have to cry. What do? Not times x to both sides. Lewis and Quinn? Make it exponential is right. All right, 5 squared is the same as 100 divided by x. Okay, 5 squared is what, Chloe? Good. 25 equals 100 all over x. Bella, how do you solve x from here? Yeah, why not? Multiply both sides by x, so I can cancel that side. If we multiply both sides by x, we have 25x on the left. What's happening to x on the right? It did. So we have what? 100. Very good. Divide both sides by Dominic. What? How do you solve x? Okay. Then Dominic, 100 divided by 25 is 4. Should I box that up? Yes, because when I check, I can keep it. Last question. Easy or difficult?
The hardest one.
The hardest one to probably? They all have log. That means it's a good thing. 2 times log base 4. I'm sorry, 2 times log base 6 of 4. Take away 1/3 times log base 6 of 8 equals to log base 6 of x. What do you do first? Make all of the, thank you, make all of your coefficient into exponent. Well said. That means this is log base 6 of 4 to what exponent? Square minus log base 6 of 8 to what exponent? 1/3 equals, and then I'm going to write log base 6 of x back. Oh, but I'm still keeping it as a minus. Can you see it? It's, remember, this is a minus. That 1/3, that 1/3 is a, huh? Then you have to change that to a positive.
No, isn't it under an exponent or a radical?
Right now, I can change it to rad, yeah. So, log base 6. What's 4 squared, y'all? 16. I'm going to write this next step. Some of you kind of already know, which that means you don't have to write that down. Okay. What's the cube root of 8? 2. So log base 6 of 16 minus log base 6 of 2 equals log base 6 of x. I'm out of space over here. How do you condense that?
You have to make y.
Matt, if your name is Matt, then you can speak. Hey, Matt.
Log base 6 is 16 over 2. Which is log base 6, 8.
Equals this side. You're right. Right? So right, I have an answer. What is it? Can I keep it? For sure. Okay. And that's an egg roll.
Yes.
If and only